Hi, I'm Hannah Spungen, and I'm currently a second-year medical toxicology fellow at UACOM Phoenix. This is the accompaniment to a talk I gave at the American College of Medical Toxicology's 2024 annual meeting. The intended audience is medical toxicologists who are just getting started learning how to use R, but if by some unhappy accident you are not a toxicologist and you have stumbled across this video on YouTube, I hope some of the content is useful to you too. I should start by saying I have no conflicts of interest to disclose, and also that there is a major caveat to all this, which is that I've never received any sort of formal training in R. What I'm about to show you is how I've taught myself to do things in R to work with my own data. So it may not be the best or the most efficient way of doing things, but it works. And if you know a better way, by all means, please let me know. Our objectives today are going to be to teach you basically how to download R, import your data, start cleaning it a little bit, and then using that clean data to make some basic but still polished looking graphs that still look a zillion times better than what most people are putting out from Excel and even publishing in some cases. Some of the most effective video R tutorials I found have been the ones where I can actually follow along by manipulating the same dataset that's being used in the video. So if you want to do that, I've uploaded my sample dataset as a CSV file to Google Drive, and you can download it here. I'll try to include a link in the YouTube description too. But just so I don't get in trouble with my employer or the IRB or anything, I've changed this data so it's made up and it's not the exact data I gathered from my calcium channel blocker overdose study, but let's just say it's close. The first thing you need to do is download both R and RStudio, and you can do that a bunch of different ways. You can use this QR code, you can use this link, or you could just Google it. It's available for any operating system. Just find the one that works best with yours and install it. And this is a quick preview of what you're going to see when you open up RStudio for the first time. So what you code or your input is going to go right here. And then when you execute that code, your output goes here. Up here is your environment. So that is what you've loaded into R, and we'll give you some examples of that shortly here. And then this pane, for our purposes, this is going to be the pane where your graphs pop up. So first things first, once you're in RStudio, we need to show you how to execute a command. And the way you do that is by using command and then return at the end of whatever line of code that you want to execute. So any code that you type goes up here, and we'll start simple. We'll do 5 plus 3. And then to execute any line of code, you do command return. So we'll do 5 plus 3, command return, and we have our output. Congratulations, you have coded in R. Obviously, R is a lot more than just a calculator, but this is just a reminder that there are a couple of built-in mathematical functions that you can use. They're pretty intuitive for the most part, and this is by no means a comprehensive list. Next, we'll talk about how to create an object in R. And an object can be anything. It can be a single value, it can be a list of values, it can be a data frame, which is the R terminology for a table, or it can even be a graph itself. But we will start with a simple example. To create an object in R, first choose a name for it. Here we'll choose X. And then you type an arrow using the less than and then dash symbols, like that. And then whatever comes to the right of that arrow is what you assign to that object. So let's assign the number 8. If I execute that command, and you execute commands again by command return, then you can see I get just a printout of what I executed, and then up in this environment, you can see the value that I've assigned to X. So from now on, if I just execute X, then I get a printout of the value I've assigned to it. So next, let's create a vector. Vectors are the building blocks of data in R because every data table in R is composed of vector subunits. We'll create a vector called glucose, and we'll assign it a couple of subunits. And in order to create a vector, you use C, and then you enclose the contents of the vector in parentheses, and you separate the subunits of that vector or the values of that vector with commas. So for this vector, we'll just come up with some glucose values: 300, 150, 89, 72. Now if I execute that, again, you can see my vector pops up in the environment tab. And if I just execute the word glucose, then I get a printout of my vector. And vectors can be handy because let's say we want to be more globally minded and convert our glucose numbers to millimoles per liter. To do that, I can just apply a basic operator and multiply the glucose vector by 0.0555. And down here, I get a printout of the converted glucose vector. And what's more, if I want to save that, let's say we'll call it glucose in millimoles, then I can just use that formula, enter, and here's my converted vector. You can also have objects or vectors that are made up of words or strings of characters. For example, let's make up a vector snakes, and that vector will consist of rattlesnake, cottonmouth, and copperhead. And if I go ahead and execute that command, then I've created a vector snakes that contains those 3 items. And if I run the command snakes now, you can see I just get a printout of those 3 things at the bottom of the screen. Now, what happens if I try to do a mathematical function on this vector? So if I try to multiply snakes by 5 and execute, you can see I get a command down here. And that's because I tried to do a mathematical function that was meant for numeric data on a character vector. And this is one of the things that you can do if you're troubleshooting your code in R. One of the easiest things is to check what class of data you're working with. And you do that by just typing class and executing that command. And as you can see here, it's telling me that it's a character vector. And that way I know that none of the functions that are designed for numeric vectors are going to work here. R divides all data into a couple of basic categories. 2 of the most basic, and the only ones we'll be covering today, are numeric data and character data. Numeric data is pretty self-explanatory. It consists of numbers and numbers only, whereas character data consists of strings, which is the fancy computer way of saying a collection of characters that aren't all numbers. In some circles, these are known as words. The distinction is important because when you import your data into R, it looks at your data table columns and automatically decides what class of data it is. Sometimes this is straightforward, for example, age and years. However, for R to consider a column numeric, it needs to consist of numbers only. So you might have a column for norepinephrine infusion rate that is intended to be numeric, but if you have a couple of entries that are coded as unknown or NA in your data set, R will probably treat those as characters, thus turning your entire column into a character column. And this becomes a problem because some functions, including a lot of the functions you might want to use for graphing your data, will only work with numeric data. So ensuring that your numeric data columns are actually numeric and fixing them if they're not is one of the most common data tidying things you'll need to do before you can start graphing your data in R. We'll go over how to do that in a second, but first we need to load some packages. So I'm about to show you how to load the tidyverse package, which is one of the most common and fundamental packages that people use in R for data manipulation. But stop, you might be saying. You're saying a lot of words, and very few of them are making sense. Well, let's back things up. So first, what is a package? To grossly oversimplify things, a package is an extension of base R that has a bunch of new commands or syntax that make accomplishing certain tasks much easier. There are packages for just about anything you can think of. There are packages for sorting your data, for doing statistical manipulations. There is a package out there that will take your graph color scheme and turn it to a color scheme of a Wes Anderson movie palette. Like you get to choose which movie. And so basically there's a package out there for anything you can think of. And tidyverse is a super widespread package that is actually a collection of packages that lets you use code that makes doing a lot of data manipulation and visualization much simpler and quicker. Please do not waste any more energy struggling about the metaphysical nature of what the tidyverse is. For our purposes, all that matters is that you need this tidyverse thing installed and loaded in order to use the rest of the code in this talk. So let's show you how to install and load the tidyverse. Loading the tidyverse is going to be necessary for all the rest of the code that I'm about to show you. And in order to install the tidyverse and load it, or any other package for that matter, you use the code install.packages, and then in quotes you put the name of the package, and once you run that, you're going to get a bunch of weird stuff at the bottom that you can totally ignore. And then in order to actually load the tidyverse, so you could install it, but if it's not loaded, it still won't work. You use the command library, and then you no longer need the quotes. You can run that command. And now the tidyverse is loaded and I'm ready to start using those commands. So the tidyverse is loaded. The final step before we actually get ready to import our data is to see what our working directory is. The working directory is basically just the location on your computer where R is going to save any R code that you write, and it's also the location where it's going to pull any new data sets that you want to import from. And you can figure out what your working directory is by using the command getwd, and if I execute that, it tells me this is where my working directory is. And let's see if I can pull this up here. So if I bring this window over, this is my computer's working. So I obviously have a Mac, so that's why the address looks like this. And this is SSD 240. So you can see all kind of the skeletons of my old R projects that are saved here. But this is the default place where I need to have my data set if I want to import it from here without modifying the command. And this is where this is a graph from my mom, this is where any new R code is going to get saved. So if I save this code here, if I just do command save, it's going to save as sample, and it'll save in our, I already have one there, so we won't replace that for now, but this is where it would save, is in the SSD 240 working directory. Now we're going to get our data ready to import into R. And there are plenty of packages out there that will let you do this directly from an Excel file format, but I'm a simple creature, and this is a fairly easy way I found of importing my data when I first started using R. So I still like to convert all of my data in whatever format it's in to a CSV file. CSV just stands for comma separated value, and it's a type of data file that eliminates all the fancy formatting stuff from the user interface in whatever other program you are using. So what you have to do now is open your data file, save it as a CSV, and move it to your working directory. So I will show you how to do that here. Pulled up the sample data set that we're going to be importing into R. And really quick, let's just take a look at what we have here. So this is a data set that has some information about a group of patients that had calcium channel blocker overdoses, or specifically dihydropyridine calcium channel blocker overdoses. So here we have GCMS results for each of them. We have which agent it was. We have age and sex. And then we have a couple of other parameters here, like some vital sign information. We have some lab information. And then one of the more important things that we're going to be working with today is the maximum rate of pressors. So we have here, were they given norepi or not? What was the maximum rate in micrograms per minute? And then we have the same thing for epi and vaso and phenylephrine and all down this list. And then we also have a couple of outcome measures here, like ICU days. Did they get ECMO? Were there ischemic complications? What were the ischemic complications? And then dispo and 30-day follow-up. So let's save this data set in a way that will let us export it to R. And so first I'm going to save, and then here I'm going to select CSV. That stands for comma separated value, and that is just a way of making your data set uniform in a way that is easier to import into R. So next I'm going to find my working directory and save that CSV file in my working directory. And it's going to give me a pop-up, and that's fine. Now we have our data set saved and ready in the right place to import it into R. Now I'm finally ready to import my data. So to do that, I come up with a name for what I want my new data frame to be called, and you want to choose something really simple because you're going to need to type it out like 1,000 times. And then I'm going to use the command read.csv, and then in quotations, because I have a Mac, I'm going to use this syntax with the tilde, a slash, and then the name of my file. If you have a Windows, it's going to look a little bit different. This tilde basically just stands for the default working directory. And again, you can change that, but just for simplicity's sake, we didn't change it here. So this is the code that you want in order to import your data frame. And if I execute that, you can see it just gives me a printout down here. And then if I go up to my environment tab, I now have a data frame. And if I click on it, then it opens a new tab that lets me preview the contents of the data frame that I have just imported. The first thing I do after I import my data set into R is to change the column names. And to do that, you run this command, colnames, and then the name of your data frame, sample. And down here I can get a little preview of what each column is titled. And as you can see, some of these are long enough that if you had to type them out every time you wanted to call up that column or manipulate it, it would give you an aneurysm. So the first thing I do is go through each and every one of these and change them into something more manageable. And it takes a while, but it's totally worth it. I'm not going to make you watch me type each and every one of these out, but this is the command you use, and the number here in brackets just stands for which column it is. And it's one thing to type all of these, you also need to run the command. And what you can see on this side is that I've just chosen a name that's easy for me to remember what it is, but still easy to type out when I need to manipulate it in code. So once you have all this typed out, you actually need to run it, so we'll do that here. And like I said, it takes a while, but the upfront investment is worth it for your sanity. And then if I go back and run this column names command, here I have much nicer and more concise column names. So anytime I do a major data cleaning or manipulation, I will save the data set as a new CSV file, so that way I can import directly from that file and not have to run every single command again. And the way you can do that is write.csv, and then you use the name of the data set that is currently in your environment that you want to save. So ours is still sample, and then you use a tilde because, again, I'm in a Mac, and I want to use this as shorthand for my working directory, and just the name of your new data frame. So we'll call this sample data 2. You could just use the name of your existing data frame or your data file, but I strongly discourage this because if you make a mistake here and you overwrite your current file, it will be totally lost. So make another file, save all your clean data to that, and that way when you re-import it into R, you can re-import the new file that's nice and clean, and you don't have to run these commands every single time. So one side note here is that you can write little notes to yourself to remind yourself what the code means and really put whatever you want. You just need to use a hashtag. Anything that comes after a hashtag, R will ignore. So here I'm going to write a little note to myself. Be careful with this, to remind myself that whatever I save as a new CSV file, I do not want to overwrite the old or the source or raw data file, because if I do that and make a mistake, then I will lose everything. So now we're ready to start going through our data to clean things up. Usually I'll do this column by column. It's painful. It's not anyone's favorite part about working with data, but it is something that's a lot easier to do with R. So an easy way to start is just to use that column names command again, just to remind yourself what columns you're actually going to, what the name of the column that you're trying to pull up is going to be. So let's start with age. Age is going to be a numeric column. So I can look at that column by using the command summary, which will give me descriptive statistics. Of course, that will only work for a numeric column. So let's try running that with, and first you need the name of the data frame and then the $, which just denotes that you're going to be specifying the column, and then you write the column, which is age. So if I run this command, here I get some descriptive statistics. I have my minimum age, max age, and then median and quartiles. Great, so that went according to plan. Not everything will do that. And by the way, if I had any missing data here, it would show me as an extra NA column. So actually, this is one of those rare columns where everything's there and in the right format. As you will see, that is usually not the case. So let's take a look at the next column, GCMS. I think that's let's look at sex. So in order to look at sex, that's a categorical variable. And so if I were to try to run the summary command, it's just telling me that this is a character vector. So I can't really get any counts of how many males, how many females are in this data set. So the way that you can do that is to use a new syntax. First, you're going to type the name of your data frame, and then you're going to use this little symbol. That's called a pipe. It's just the percentage greater than percentage. And now I can do count parentheses sex. And then if I run that, it'll give me a frequency count of female and male. So likewise, I could do the same thing with the ischemic complications, which I called isc.type. This is a count of each of the types of ischemic complications that were recorded here. And last but not least, let's do a count of the 30-day follow-up. So this tells me 47 alive, 5 dead, 16 unknown. This is just a good way of exploring your data set. There are a couple of other ways you can do this that don't work as well, but they may come in handy for you someday. If you use the command head, and then let's use the GCMS column. Oh, but first you need to specify that you're in the sample data frame. If I run that, I'm going to get just the first few entries of that data frame. So sometimes it's useful for telling you how the formatting is, but other times like if I were to use that with sample isc type, there's so few ischemic complications, it's just going to give me a whole lot of nothing. So this is a good way to kind of go through your data frame and make sure everything's in the right format. So let's show you an example of something that's not in the right format. We will now look at let's try and look at a summary of the maximum norepi rate and what the median max norepi rate is and what the summary statistics are. So again, I do sample $any.dose. I'm sorry about the dose terminology. That's just how I have it in my brain, is how I'm going to enter the rates. So again, if I execute this, the problem is that it's a character. And next we have to figure out why. What is being coded as a character that's making a column that should be numbers into a column of characters? And the way you do that is this exact same code. If I just substitute in any.dose, I'm going to get a really long thing here, but the reason I like to do this to figure out what's wrong with my should be numeric data columns is because it puts all the characters at the end. So I can see I have one column here that's an N and another column here that's a U. Those should both be coded as NAs, or R's terminology for missing data. So because I don't have any other data here that would get lost if I bulk converted anything that's not a number to an NA, I can do this in one fell swoop. I can fix the type of column by just doing sample any.dose and then the arrow and as.numeric, and then I just type it all over again. And I'm going to get a warning that says NAs are introduced by coercion. That's a good thing. That means anything that was not a number was coerced into being NA. And now if I run this command again, now I have no more NAs, and I could probably even do the sample, and now it's actually giving me the descriptive stats that I want, and it tells me that there were 29 NAs, or 29 patients who didn't get any norepi at all. To illustrate one of the other common things that comes up when you're cleaning data, let's take a look at the types of calcium channel blockers that were involved in these cases. So to do that, we can do sample, and then we can do count and parentheses, and then the title of that column is CCB agent. So if I run this command, I get two separate amlodipine columns, and that's because the import function is case sensitive, which is a mixed blessing. But in this case, it means we have to do some data tidying. And it's pretty easy but pretty tedious to fix this. So in order to replace all of the lowercase amlodipine instances with the uppercase that we want, you sample and then the name of the column, and then you do the same thing again in brackets, and then two equal signs, and then in quotes here you want whichever the one you want to be replaced. So the one with a typo or the one with the wrong case. And so here it's the lowercase amlodipine, and then we're going to use the assignment arrow. And then in quotes again, we're just going to put what we want to replace it with. And if I run this command, now if I go back and I execute this, now we fixed our problem. So everything's going to be counted as all the amlodipines are going in one category, which is what we want. Next, I'll show you how to create a new column using data from one of your existing columns, and that is by using a command called mutate. Let's create a new column with the lactate values in milligrams per deciliter. So we start with our data frame, little pipe, and then we'll do mutate is going to be this command. And then we'll call this new column lact.mgdl, and we will make it equal to the lact max times 0.111. If I execute that command, we get this weird thing, and that's because I actually have to overwrite the existing data frame with this new mutated column if I want it to save. And now that I've done that, I can open my sample data frame and I can scroll all the way to the end. And look, now I have my converted data lactate units. Nobody cares, but that's a simple example. So let's actually make a column that we care about, and that is going to be whether the patient got pressors, yes or no, because all of the existing columns just say, did they get epi, yes, no, did they get norepi, yes, no, but I don't have any one column that sums all of those up. This is going to be a much more complicated mutate command, and because of that, I'm not going to make you watch me type it out, but I will walk you through it. So we have our sample and then our little pipe. And then the mutate command. We're going to call our new column pressors yes, no, and we're going to use this command case when. And this is going to be a bit of a double negative here, but if all of these conditions are satisfied, if the nor epi yes no answer is no, if they didn't get epi, if they didn't get vaso, if all of those are satisfied, then we give a no. And there's a little tilde there. Then you use a comma, and don't ask me why this is, you just have to memorize it or copy paste it. True, tilde y, and then if I run that command as is, of course I get this weird, bizarre thing down here, and that's because I have to actually overwrite the existing data set in order to save this new column. So now that I've done that, let's look at our handiwork. And if I go over here, ta-da, I have a presser column. And I can also do sample count, press yn, and there's our little summary. Now let's use our new presser yes no column to compare the lactates between the people who did and who didn't get pressors. And to do that, we need to use another one of the dplyr functions called filter. So to start off with, let's isolate the group of people who did get pressors. And we can do that by typing sample, the pipe, and then filter, parentheses, press.yn equals, and it's important to put 2 equals here, y. So this will give me all of the people who did get pressors. And again, to save that as its own data frame, I'm just going to name the data frame presser and define it as this filter. And if I run that command here in our environment, the new data frame presser shows up. So we can do the same thing with the people who didn't get pressors. We'll call it no presser. And that's all the people who had a no in our press.yn column. So if I run that, now we have these 2 separate data frames. And if I look at the presser $lact max, oh, we want a summary of that. And I can compare that to a summary of the no presser lact max. And unsurprisingly, the median value of lactate in the people who did get pressors was much higher than the people who didn't. Fantastic. So now that we've covered cleaning data in 15 minutes, which in reality will probably take you on the order of hours, next we can finally start to talk about graphing. So the tidyverse package that we installed included ggplot2, which is the graphics package we're going to use for R. And this slide will show you what a basic line of ggplot code looks like. So you have the name of your data frame here, and I put the equal signs in. Sometimes they're helpful to leave in when you're first learning, but you don't actually need mapping equals and data equals. It's kind of implied, and you can leave those out. So the first line is just going to be ggplot and then the name of your data frame. You can put aesthetic mapping up here too. It will vary. It will depend on the situation, and I'll show you that in a little bit. But all you need to know is that you need the name of your data frame. You need what type of graph you want. So that is called a geom. And when you put in a geom, you add it as a separate layer. So you use the plus sign, you return, it'll auto indent for you, and then you type geom underscore in whatever type of graph you want. So let's say we're doing a bar graph, it'll be geom underscore bar. And then after you type your geom, you have to have a set of parentheses. And if you didn't already specify where your data is going to be coming from, other than, we have our sample set, but which column are we doing a bar graph of, that goes in your aesthetic mapping. And again, you can drop the mapping, and what you put in aesthetic, you're going to use another parentheses here, that just tells you what gets mapped to the x-axis. And if it's a scatter plot, what also gets mapped to the y-axis. And then you can add another argument that tells you, do you want to add a fill or change the color based on another categorical variable? And I will show you how to do that in just a moment here. For our H histogram, we'll start with ggplot, then we're using our sample data set. We're mapping to an aesthetic where the x-axis is age, and since it's a histogram, there's no y-axis, and then geom underscore histogram. And bam, we have our histogram. And it gives you this thing about the bin width, but it's usually pretty good about whatever its default setting is. You can also change it easily. So let's do another one. Let's do ggplot sample, and then this time let's do a box plot of our norepi dose. Okay, so this is hideous, but wait, we can fix it. First, I just hate it this way, so let's do chord underscore flip. Great, but it's still ugly. So next, in the boxplot argument, let's add the argument fill equals blue. Okay, that's prettier. So one thing you can do is copy paste this. Let's do the same thing for epidose, but we'll make the epi light blue. And I love that it automatically makes it the color for you. And then last but not least, let's do phenylephrine dose. And phenylephrine just feels orange to me. So we'll do that. And then, okay, wait, it gets better. Then we're going to name each of these so they're easier to work with. See? Great. And now let's put them all on one plot. So this is actually a separate package, and I'll show you all the packages I think you should download off the bat. GGarrange, A, B, C, and then I want to add n row equals 1, so they're all in a row. And wow, it's beautiful, isn't it? And it's also misleading because these are not the same axes, so they're not lining them up like that creates this false equivalency, but I think it's still pretty. Now that we've plotted some numeric data in a histogram, let's plot some frequency data with a bar plot. So to do that, start again with ggplot, and then your name of your data set. So you can either put your aesthetic command here, or you can actually put it in the individual geom layer. So let's do that this time. So if I do the plus, and then every new thing that comes after a plus is just another layer, then we're gonna add our geom layer, and this time we're gonna do a bar plot. And this time our aesthetic mapping is going to be that the x-axis will be, let's do a frequency count of the number of each calcium channel blocker agent. So we'll do CCB agent, and if I plot that, here is our bar plot. Now one of the ways that you can kind of play around with and visualize your data is to add a fill here. So if we add the fill for, did they get pressors? Yes, no. And I run this. Here I get a breakdown of how many in each of these categories received pressors, and this is actually kind of interesting because it tells you that even though there were way fewer nifedipines, proportionally speaking, far more of them actually did end up getting pressors. And you can play around by substituting out pretty much any of the categorical variables. So I could change this to intent and did they get pressors? I can change this to intent and did they have an arrest? Or did end up on event? So it's really, really quick to make a bunch of different plots that will help you kind of visualize your data, look for outliers, and look at interesting patterns. Now let's plot some bivariate data, and we'll do that by making a scatter plot, and we'll plot the maximum lactate versus the maximum norepi rate. And to do that, again, we start with ggplot, the name of our data frame. Now I could put my aesthetic mapping here where I would do the x-axis is going to be our max lactate, our y-axis is going to be our max norepi rate, and then I could just do geom underscore point, which is the geom code for a scatter plot, and that works. I can also take the same aesthetic mapping and put it in the geom point layer and delete it here. If I run that, it gives me exactly the same thing. Sometimes, depending on what sort of tweaking you're going to do for your theme and for the formatting of your graph, sometimes it behooves you to put the aesthetic mapping up at the top, and sometimes it's better to keep it in each individual geom layer. That will vary. But the only reason I'm bringing this up is you may see me switching back and forth between where the aesthetic mapping is. For the purposes of very simple plotting like we're going to do here, most of the time it doesn't end up mattering. So just to keep it neater, let's move this aesthetic mapping back up here. And then then you just have geom, oh, sorry about that. Then you just have an empty geom point, and then you can also add a regression line. And to do that, you do geom underscore smooth, and then method equals LM, and that stands for least means. There's a bunch of different methods you can use. So if I plot this, here I have a regression line that gives me some standard error shadowing. And if I want to remove that, I could just do SE equals false. And let's say, we don't really need our regression line here, but let's say I have my graph again, and I just want these points to be a little bit bigger. I can just add size equals 3 or however much bigger you want them. And here I have a slightly, I think it's the visibility is a little bit better. So another thing you can do with your scatter plots is add a fill, except it's not called a fill. So when you're working with a bar graph, if you want to stratify by subcategory, it's called a fill. If you're working with a scatter plot, it's called color. And I hate it. I don't know why that's the word for the argument. It is what it is. So if I add color here, then I can choose a different categorical variable that I want to stratify by. So let's stratify by 30-day follow-up. And if I run that code, it gives me a key here, and it's coding each of these colors will correspond with whether they're alive, dead, or unknown. And I mean, it's kind of interesting here. Let me, no, I don't want to do that. I want to zoom to show you a slightly better view. So this is kind of interesting because, I mean, it's not surprising that the maximum norepi dose had a middling lactate value. What is also not surprising is that they ended up dying. So cranking up the norepi to 200 maybe didn't help so much. But did it hurt is the question. Well, we can see if they had ischemic complications. So let's run that plot, and interestingly, yes, they did. So let me make this a little bit bigger. Of course, this doesn't tell me if the ischemic complication is from the norepi dose. It's possible that somebody who's going to die anyway was just really sick and had an ischemic complication from hypotension, but it is interesting to see it play out visually in this plot, and that's why I like to play around with different fills for both the scatter plots and the bar plots. Okay, so we're pretty proud of this graph, and we want to make it a little bit prettier. So what we can do is we can add a title and we can add labels, and we do that by adding an extra layer called labs. And just so you don't have to watch me type it all out, I've used the argument title equals, y equals, and x equals for each respective axis. And then to label your legend here, you use color as the argument. Don't ask me why again, it's frustrating, but it is the way it is. So if we run this, now we have our titles. And another thing you can do is reposition the 30-day follow-up legend. So I could add another layer that says theme parentheses legend dot position equals bottom. And if I do that, now our legend is repositioned. One final bit of customization I will show you is how to center your title. And unfortunately, it is not intuitive. If you're anything like me, you'll have to look it up every time, and sometimes that's just life. But this is the code that you run. The HJust, the horizontal justification, should be at 0.5, and that will center your title. So if you are aesthetically challenged like me, the good news is there are built-in themes that make making polished graphs much easier. So first thing I recommend saving your big bulky graph code is just a letter to make it easier. So then I can take this letter and then add a layer that is just theme minimal. And here you can see the minimal theme. So this is with the package GG themes. There are a bunch of them. Some of them are better than others. So we have theme dark. I don't know why you would want that. Likewise, theme solarized 2. Not sure why you would want that either. Maybe you're a fan of Dune. You can do the Wall Street Journal theme. That's a no thank you from me, but some people like it, I guess. And same thing with The Economist. It doesn't tend to do as well when you're trying to subset when you have this key up here. So one of the themes that I like the most is the theme calc. And I just think it looks neat with the horizontal axis bars. And then after that, you can also add another layer that is scale color calc. And look at that, that's much prettier. And by the way, because when you add a new theme, it overrides the old theme, you may need to add this back if you want to recenter the title. Before we end, I did want to give you a quick list of packages that I recommend. You don't need to load all of them for every R project, but depending on what you're trying to do, these can be super helpful. Some of them are just pretty color palettes, but others are very functional. Lubridate and HMS in particular are vital if you're going to be working with data that has any sort of date or time info. And I think we'll end there for today. If you still feel overwhelmed, that is okay. A lot of the confidence you'll gain in R is by just starting to use it with your own data and solving the problems that arise as they come. This is a list of reference resources that I found to be super useful for teaching me R fundamentals and filling in some of the gaps in my foundational knowledge of R. But when it comes to solving a problem in your code, Google is your best friend. There are tons of sites like Stack Exchange where people post reproducible code of their R issues, and smart data science people solve them. Ultimately, R takes a long time to get reasonably facile with, but once you do, you'll wonder how you ever dealt with data before. And as always, if you're ever stuck and want a second set of eyes, feel free to email me with the info I gave out at my talk. Thanks so much for your time, and happy coding!